I've been interested in solar vehicles since 1985 when we started building the car for Dick Smith. At that stage a solar race had been proposed, and that race was to go from Darwin to Adelaide, 3,000 kilometres across the centre of Australia. In 1987, when we built our car, the best solar panels that we could get were about 14% efficient. Now it's possible to get commercially available solar panels that are more than twice as efficient, 30% efficient. I don't think it will be another 20 years before we see possibly 60% efficient solar panels. In parallel with that, of course, has been the development in batteries and power electronics and motors, all of which have become much more efficient and much more reliable. And so it's now, I think, possible and sensible to conceive of something as challenging as this Solar Dog project, where you take all of this technology and put it into the harshest possible environment.
I'm saying goodbye to my beautiful little Solar Dog after about 10 years, and it's going to be great to see that it might end up at the South Pole.
This is the most isolated continent in the world, and it's cold. There's no one nearby if things do go wrong, so the team are going to have to be very self-reliant. My own research has been based at these high altitude sites. South Pole itself is fairly high, it's about 2,800 metres above sea level. I think there's a lot of things that could go very seriously wrong. Well, breaking down is the hazard that you want to avoid, and particularly close to the coast is the potential for blizzards. Although there are huge challenges in building a vehicle to travel across Antarctica, there's also huge advantages. One of them being that, of course, in the summertime you've got continuous daylight.
You can see this panel here, it has a very high tilt on it. The sun is about 23 degrees in the sky, so it's about this angle. And so we run for 6 hours when the sun is on this angle. We stop when the sun comes around in the front. We bring the panel down, it's on a tilting frame here, it comes over this side, and we run for another 6 hours. As you get inland and closer to the pole, the wind drops down to very low levels indeed, so you can be sure of low wind speeds. On the other hand, of course, there's the very low temperatures that could easily get down to -35 or -40 Celsius. And the snow, the fact that this vehicle is going to have to travel across what could be quite thick and soft snow, and that's going to require some careful design of the tyres and the suspension. We look at the motors. The motors are all the industrial permanent magnet motors. They're robust, they're reliable, and it proves that these sorts of technologies, high efficiency, high reliability, can be used in very tough conditions. Antarctica is the toughest you can get. The
basic design that is there is a very sound one with the 6 wheels and each on its own independent suspension. It has to be light, it has to be very strong, fat tyres that can cope, they won't sink in too much, and it has to be simple because things could break. And it's much easier to fix a broken simple thing than it is to fix a broken complicated thing. It's worth remembering that it's only 100 years since the very first people went to the South Pole. So 100 years later, here is a team doing essentially the same thing, but this time powered by solar energy rather than by horses or dogs. And we're all hoping that they will make it safely back to base.